Hello, my name is Ali Purbe, and welcome back to Newton News, your source for everything engineering. On today's show, we're going to dive into a project that a group of young engineering students have been working on for a few months. Their project aims at improving the quality of life of their patient, Miss Liu, who suffers from an autoimmune disorder, which results in the inflammation of her joints. As a result, she has difficulty moving her metacarpals and thus cannot close her hands into a fist shape. Autoimmune diseases are characterized by systemic inflammation, where a dysregulated immune system causes damage or dysfunction to target organs. They impact over 7% of the general population, and similar diseases include rheumatoid arthritis, lupus, and multiple sclerosis. Although there is no direct cure to many of these disorders, current solutions include anti-inflammatory drugs, steroids, therapy, and surgery. Despite these current solutions, depression rates can reach over 42%. So this group of individuals believe that they can develop a device for Miss Liu to assist her fine motor skills and make her more independent, since the lack of mobility in her hand joints from her autoimmune diseases causes pain and constant discomfort. According to the team, the device aims at being lightweight, easy to use, comfortable, and portable while meeting current constraints of not requiring fine motor control and allowing for independent use, which will aid in improving her motor control. I will now pass it on to one of the designers, Ben Tonka, who will address the device's design.
Thanks, Ali. Our team has developed a device to help Miss Liu with various tasks, some of which include opening doors, opening water bottles, and gripping various objects. All of this can be done with the press of a few buttons. The device has two major components. The top component has a claw shape and is able to open and close around various sized objects. This entire component is able to rotate in a twisting motion. The bottom component, or the base, has a customized shape for Miss Liu to hold easily with an open hand, and it has 4 different buttons, 2 of which are for opening and closing the claw, and the other 2 are for rotating the claw in both directions. The device has 2 motors. The first motor is on the top component of the device and is connected to a series of gears to open and close the claw. The second motor is embedded in the base of the device and attaches to rotate the upper component. These motors rotate depending on which button has been pressed. The buttons are fairly intuitive for the client. The left button rotates counterclockwise, the right button rotates clockwise. The up button closes the claw, and the down button opens the claw. The motion of these motors is stopped as soon as the same button is pressed again. The device was designed specifically for Miss Liu and will be able to aid her in several aspects of her everyday life. Not only will it help her open doors and water bottles, it will also be able to help her grip any object that may have typically caused her pain. This will give Miss Liu more independence and allow her to do tasks she could not have done before. The design allows her to maintain a comfortable open hand position while using the device. The claw has a varying range, extending from 9.6 centimeters all the way down to 1.3 centimeters. The claws have jagged surfaces and are covered in rubber to allow for maximum grip. The device has all of these features, all while maintaining a relatively small size for easy portability. This device is tailored directly for Miss Liu and has many features to help her in her everyday life. The development process was no easy task. I'm going to pass it on to Lauren Stevens to discuss the development in more depth.
Thanks, Ben. It certainly has been a journey designing this device for Miss Liu. Our preliminary prototype was constructed using materials found in the design studio, including a sponge for the base, a spinning disc, 2 gears, and pipe cleaners for the claws. Though rudimentary in its design, it conveyed the different ways the final design could move and interact with objects. The pipe cleaners could open and close, show the movement of the claw, and the disc could spin on a center axis, showing how the unscrewing of a cap or twisting of a door handle would be achieved. From this prototype, we decided what mechanisms we would need to include to drive each movement, and we also learned their relative location. The second prototype we made included a 3D printed claw design, wooden boards for the base, and a sketched out layout of the different electronic components, including the breadboard, Raspberry Pi, buttons, and motors. This prototype had the components that were needed in the final design and conveyed how the different mechanisms would interface. We wanted to use this prototype to evaluate the new claw design, and we learned that it would work very well for our device. We also learned that our new focus should be on making the device more portable. Our final prototype was more of a series of revisions that made our device more portable and easier to use. This included adding a grip on the claw, reducing the claw size by 25%, and discovering we could use a smaller breadboard coupled with a motor driver to drastically reduce the size of the base. Through each revision, we wanted to evaluate how it would improve the device and make it more feasible to use in daily life. The added grip would ensure it didn't slip on any surfaces, and reducing the size of the claw and base made it easier for Miss Liu to use because it could be held in one hand and stored in a bag or backpack. Next, we'll hear from Helen Lee on the potential next steps of this design.
Thank you, Lauren. Now, let's move our attention to the high-fidelity prototype. Unlike the second prototype, this one has a 3D printed body. All the buttons and motors are attached to the board. One of the two motors is embedded into the base to reduce the dimensions. Here's a short video to show the simulation demonstrating how the device will work. By pressing the upward button, we're able to close the claws to grab objects. If we need to release them, we can do so by pressing the downward button to open the claws. By pressing the right button, we can rotate the top component clockwise for any twisting purposes. If we wanted to rotate in the opposite direction, we can press the left button. For our ideal design, the Raspberry Pi and the breadboard will not be used in the device, as smaller alternatives are available, which saves us a lot of space. The device will be smaller in terms of the size and weight compared to the other prototypes, with a base that's the size of a calculator. With this design, Ms. Liu will have no problem using it with one hand, which is our intention. Under normal circumstances, we will 3D print the parts and assemble them together. Then we will try it on doorknobs, water bottles with various cap sizes, and many other small objects. Once we make sure it works, we will let Ms. Liu try the device and get some feedback from her to further improve our design. Just like my colleague Ben said, after all the adjustments and improvements, our final device will be able to help Ms. Liu open doors, open water bottles, and grab objects. This would make her more independent, improving her quality of life. That's all for today's Newton News. Thanks for watching and see you next week.